Hi guys, I'm gonna start today's problem. So I selected this one, meeting room 2. This was asked by Bloomberg, Amazon, Apple, and wow, Google a lot, and Facebook, MS, Oracle. Wow, very famous problem, I guess. Meeting room 2. Okay, let's start the timer. Let me start the timer. Okay. So given an array of meeting time interval where interval I is start and end, return the minimum number of conference rooms required. Okay, so this is overlapped, and this is overlapped, right? At the same time. Okay, so 3. What, 2? This one. Oh, this one and this one is not overlapped. So here I said 2, right? And then the answer is 2. I said 3. So why I thought that this one and this one and this one are all overlapped. So I thought that it's 3, but it turns out that this one and this one is not overlapped. So yeah, so that was the reason. So if this one and this one is overlapped, we can find the overlapping time. Which one is this? Which is this one? Overlapped time. And then also we can check whether that overlapped time is overlapped with this one. So let's say that there's there's n number of rooms, and then among n number of rooms, so how many time intervals do we have? So this is, the whole company has a lot of meetings. And then end is of course less than start is of course less than end, right? And then end can start from 0 and then start, and then the end time is less than this number. Pretty large. So what we can do is that the easiest way we can think about is that, okay, this one, let's think about this one, and then it loops this and this. So let's think about this one, and then it has some overlapped time, so we can calculate the overlapped time, and then we can check whether this one has in the overlapped time. What if so let's say 0, 30, 0, 20, and then 0, 10. So in the case, the overlap time with this one and this one is this, and then that overlap time with this one is this. So we need 3 rooms, right? Then let's say 10, So in that case, well, they have 10, 1, 10, but this one doesn't have overlapped. So from here, all level 3 has the overlapped time. Then if we see this is 110. This doesn't. So this is not the right way. So, well, thinking about this one, we need 2 room. Then finding this 1, 0 is the minimum. But we already find 1, 0, right? Then anyway, this one is out of. So it seems like these are not the. This one. So the question is, let's say this. In that case, we need to know that this has 1 room, and then this and this has another room. Let's draw 130, and then 120, and then this. So for this guy, it knows that this one, and then if there's anything like this, then from this 3 room, from 1 to 3, right? That is a room A, room A, room A, room A, B, C, the room C, and then at this point, also 3 room. So one easy way to solve this is to prepare array of this. I mean, array of this size, and then we can check whether each one has the other way around is that the other way around is that, let's say that there is a big meeting, whole day meeting, then if there is anything, and if we see this meeting inside the array, then how do we know that this has pieces meeting. This one and this one is overlapped. How does it know? By looking at this. How does it know? How does it know? This one. So this one need to look back, right? Which means n square, all over n square. But if we can construct some kind of structure, then would it be easier? Like structure is like the array I mentioned before, or something else. So let's say that this is very complicated one, like this. So if we see, then somehow this one is entered, then that will increase some meeting room. So it needs to check whether there are any previous ones. But how? How do we have this kind of structure? Previous structure. So think about map, no, or some kind of tree. I don't think so. So by looking at this, if we provide this range, this will, for example, but I don't need to keep track of any, but keep track of all the meeting rooms. If we don't keep track of all the meeting rooms, then we are not gonna get the maximum meeting room for this by introducing this. So we have to keep track of everything. And then what if we have range this and range this, the same range, and then the same range again and again and again. Then, you know, if we have this kind of structure, then everything in between will be wasted. So we can have some kind of simple architecture, simple mechanism, some structure like like start and then count. So if we have this kind of structure, for example, zeros and then 60, count was now 1. We'll say that this is 60, this is 0, 60. So 0, we got 0, 20. So by looking at this, oh, now we have a 0, 20, and then this needs 2. And then this one, 30, 40. This one is 2. Why? It looked back and then took back this one and this one. So this is the same with keeping everything in here. So this will be n square again. Any better way to it's very tempting. Like vector int count like 1, 2, 3, 4, 5, 6. This is very tempting approach. Not very good. So by looking the start, there's gotta be some structure. By providing this, it returns this, not this. But to return this, you need to check everything, every scope. And then if we solve this with n square, this means the n4 to the power of n4 n square, which is too big. Oh, so difficult. Oh, this is very difficult. So if this is given, somehow it you to get 3, and then 4, so you need to get 3. So actually, if I store some data structure, like from here, count is 2, here, like if we divide this into some structure, and then if we can keep the structure in sorted order, there is also one of the difficult things. It will be doable. So for example, let's say we added this, and then we have this one, so 0, 60, this 0, 20, and then it gives us it splits the structure 0, 20 to 22, 60 to somewhere. Then if we give this, it will, this one is overlapped, this one is overlapped. So it will somehow give us 0, 3, 2, this structure, which means that we have to split that into, we have to split this one and this one into 2. But with the array, this kind of split is difficult because we have to shift all the thing. Maybe we can use list. So we can use list, to insert this. And then as a next turn, if we have this one, you have to split like we have like this one. We have to split this. But this is way overcomplicated, I think. Making such structure. List. Since it is list, insert clear insert history. Oh, I don't know. Yeah, because if I make this kind of structure in array, it is doable. But finding, let's say that this one is added. So in that case, we have to find this range inside the list. So since it is a list, we have to go through the list again. So it is also n square. If you don't want to go through the list, maybe we can use map. But with map, we cannot store this kind of range as a key. So for example, can we get this range and this range and this range from map? I don't think so. Even though map might provide some kind of key function, I don't think so. Or we can make some kind of array. Yeah, but this length is pretty long. So if we, first one is this, first one is this, and second one is this, and third one is this, fourth one is this. In the case, we need 2 multiplied by 10⁴. It's too much. So I don't actually know what's the best data structure I can use for this. Some ranges, number of ranges, and then with which we can find with O of n. If we find O of n time complex, then this question will be of n problem. Okay, so I have to see the editorial. So this is private function. Yeah, all the premium function, although all the problem is the premium function. So let's finish this here. Well, today was not a good time for me. Okay, bye.